Part H of question 6 is asking us to find angle AFC. And so just to indicate which angle that is in this complicated diagram here, angle AFC is this angle here that we're interested in. So I'm going to draw a dot there to indicate it. And so what we want to remember here is the rule that if the two have the same arc, an inscribed angle is 1/2 of a central angle. So in this case here, we have the central angle of 150 degrees that has this arc of the circle here. And we have two inscribed angles here and here that both have the same arc. So we can say that these angles are 1/2 of our central angle, or 1/2 of 150 degrees. So 150 degrees divided by 2 is 75 degrees. So this angle here is 75. This one here is also 75 degrees. Okay, so now we can look here. We have a straight line. We know that this angle is 75 degrees, and to make a straight line, this should add up to 180 degrees. So 180 minus 75 is 105 degrees. And so this angle here is 105 degrees. So now we can look at this triangle we have here and see that those angles should add up to 180 degrees as well. So 180 degrees minus 105 degrees minus 40 degrees is 35 degrees. So this angle up here is 35 degrees. So now we can look at the smaller triangle we have here. Again, the angle should add up to 180 degrees. So 180 minus 75 minus 35 is 70 degrees. So this angle down here is 70 degrees. And again, what we have here is a straight line. So these two angles should add up to 180 degrees. 180 degrees minus 70 degrees is 110 degrees. So this angle here that we're interested in is 110 degrees. So angle AFC is 110 degrees. And that's the answer to part H of question 6. Part I of question 6 asks us to find angle A in this diagram. And so what I think is a good way to answer this problem, it might not be the only way, but it's the way I figured it out, is by looking at angle A and seeing that it's a just inscribed angle with this chord here, which I'm going to draw with a dotted line. And so we know there's a relationship between inscribed angles and central angles with the same chord. So what I'm going to do is draw a central angle with this same chord here. Those should be straight lines. And see if we can figure out this central angle here, because if we can figure that out, we can figure out this inscribed angle. And so what I'm going to do is I'm going to assign some variables to angles here, because if we can see, we have essentially, when we draw these lines in, two triangles here. And we don't know exactly what their angles are, but we can come up with expressions for them. So in each of these triangles, these two sides are equal to the radius of the circle because they come from the center of the circle to the edge. So that means that these two angles down here are going to be the same measurement. So I'm going to call that x and x in this case. And in this triangle, if these two angles are x, this last angle, to make all the angles add up to 180 degrees, this last angle must be equal to 180 minus 2x. Okay, and in this triangle, we can come up with the same scenario. So these two angles are going to be the same measurement because these two sides are the same and it's an isosceles triangle. So I'm going to call them y and y in this case. And this angle is going to be 180 minus 2y. In this triangle we have here, if we draw this chord in, sorry, pretend that's a straight line. We again have sides equal to the radius. And so this angle here, which is this full angle, I'm going to call A. This angle down here, I'm going to call A as well. So all the way to this line that I've drawn. So this angle in the center is again going to be equal to 180 minus 2A. Okay, so if we look at what we have here, this line is a transversal of these two parallel lines here. We've been told they're parallel by these arrows, and this line reaches, or doesn't quite cross, but reaches both of these parallel lines. So we can remember our rules about parallel lines. When we have a transversal, these two angles on the inside are going to add up to 180 degrees. They're supplementary angles. And so if we remember our expressions for these angles, we can write an equation where 21 plus x plus a plus a again plus y equals 180 degrees for these two angles to be supplementary. And we can simplify this by combining our a's, so it's plus 2a, and also by moving our 21 to the other side. So I'm going to subtract 21 on both sides. That gives me x plus 2a plus y. 180 minus 21 is 159. So I'm going to leave that like that and call this equation 1. We'll come back to that in a second. So we can come up with another equation looking at the center of the circle here. And we know that a circle has to add up, or the angles have to add up to 360 degrees to make a full circle. So let's add up these angles. We'll say 31 plus 180 minus 2x plus 180 minus 2a plus 180 minus 2y equals 360. So we can simplify this by quite a bit. Adding 31 plus 180 plus 180 plus 180 is 571. We have a minus 2x minus 2a minus 2y equals 360. So I'm going to move these terms with our variables over to the right side to make them positive. So I'm going to add them to both sides of my equation. Gives me 571 equals 360 plus 2x plus 2a plus 2y. I'm going to subtract 360 from both sides. 571 minus 360 is 211. That equals 2x plus 2a plus 2y. So we can simplify this even further by dividing both sides of our equation by 2. 211 divided by 2 is 105.5. And the 2 cancels out the 2's in each of these terms, so we're left with x plus a plus y. And I'm going to call this equation 2. So now what we want to do is combine these two equations. And what I'm going to do in this case is take equation 1 and subtract equation 2. So equation 1 is x plus 2a plus y equals 159. Equation 2, I'm going to rearrange it, is x plus a plus y equals 105.5. And I'm subtracting these two equations. So x minus x, 0. 2a minus a is just a. Y minus y is nothing. And 159 minus 105 is 53.5. So we've gotten lucky here, and our x and y variables have canceled out, and we're left with a, which if we look at our diagram, that's what we're really interested in. We're interested in this central angle, which is in terms of a. So now that we know A, we can figure out what the central angle is. So our central angle, write that out, central angle set as 180 minus 2A. And now we know that A is 53.5. So 2 times 53.5 is 107. 180 minus 107 is 73. So we found that this central angle is 73. So if we remember a relationship between central angles and inscribed angles with the same chord or same arc, we remember that an inscribed angle is equal to 1/2 of a central angle with the same chord. And so that means that our inscribed angle in this case, which is angle A, is equal to 1/2 of our central angle, which we found is 73. And so 1/2 of 73 is 36.5. Remember, all our units are in degrees here, so angle A is 36.5 degrees. Write that in. And so 36.5 degrees is the answer to part I of question 6.